Nuclear energy, the science that takes radioactive materials and uses them to generate electricity. It's such a complex and specific science, and yet, it's actually quite simple.
If you don't know how a nuclear reactor generates electricity, here are the very basics. We take radioactive materials and put them super close together. This generates heat and radiation. The radiation is mitigated by something called control rods and water. Meanwhile, the heat is used to evaporate water into steam and turn a turbine, thus generating electricity. And actually, that last stage of steam turning a turbine is how most of the world generates electricity already. And that's what's great about nuclear power. See, the electricity that gets sent to places like this and distributed across cities is made by burning fossil fuels, which pollutes the environment. Meanwhile, nuclear power generation only makes steam, clouds. And you might worry that that steam may be radioactive, but it isn't, because the water that's evaporated is from an entirely separate system. It's literally harmless.
Then there's the waste. As uranium fuel depletes over time, it becomes less usable, but remains all the more deadly. So do we just bury it, toss it in the sea, shoot it into space? No, of course not. We use safely engineered and nearly indestructible containers to safely store the fuel with other materials that will again make it essentially harmless. Unless of course you somehow bust one of those things open.
Combining these facts with others, like for example how nuclear power is over 8,000 times more efficient than burning fossil fuels, easier to manage, and probably to your surprise, better for human health, why is it that we're not using this science to keep the lights on?
There has been a nuclear accident in the Soviet Union, and the Soviets have admitted that it happened. The Soviet version is this. One of the atomic reactors at the Chernobyl atomic power plant near the city of Kiev was damaged, and there is speculation in Moscow that people were injured and may have died.
On April 26, 1986, Earth faced something that has never occurred naturally in 4.5 billion years of history. When reactor number 4 at the Chernobyl nuclear power plant exploded, it sent metric tons of radioactive core materials, waste, steam, ash, and smoke into the atmosphere, contaminating tens of thousands of miles. The area surrounding Chernobyl will remain uninhabitable for 20,000 years. This disaster, along with others like SL1, 3 Mile Island, and most recently, Fukushima Daiichi, coupled with obvious threats of atomic bombs, you can see why the public associates the word nuclear with death. And the most dangerous aspect of nuclear physics is of course an explosion, like from a bomb. But in a close second place is what comes after, the radiation.
Hollywood would have you believing that radiation-induced mutation would give you superpowers or have you growing extra appendages. But the reality is far more horrifying. When radiation messes with your DNA, it destroys your bone marrow, kills your immune system, makes it so your brain can't fire neurons, and more or less melts you from the outside in and the inside out. If you were in or near Chernobyl when the accident occurred, your life expectancy would be relatively cut in half. And if you were one of the unlucky many first responders or plant workers at the time, the amount of radiation you would receive would give you more or less 2 weeks to live. But is it all doom and gloom? No, actually. If anything, these disasters have shown us how not to use nuclear power. Over the many decades, we've come up with new sustainable fuels like thorium, new technologies and designs for power plants that can contain and prevent disasters from happening again. But while we can construct new power plants, make new technologies and new fuels, the one thing that's harder to rebuild is trust.